Oh, hey everyone, Justin here. I'm still at the mall shopping for some clothes now. I found a lot of good stuff at this store I'm at, but my basket is kind of a mess. I want to organize everything I'm getting, but I have to figure out how. I could use your help. All right, here's everything that I'm buying: 2 shirts, 1 pair of shoes, 2 hats, 2 hoodies, 3 more hats, 2 more shirts, 1 more pair of shoes, and 1 more shirt. How can I organize my stuff? Well, what would make the most sense? Probably making groups of all of the same items, like the first 2 shirts would go with the other 2 shirts, and the other 1 shirt. The 1 pair of shoes would go with the other pair of shoes. Hey, this reminds me of the concept of like terms. Just like how shirts go with other shirts, no matter where they all were in my original pile of stuff, we can find terms that go with each other in algebraic expressions. Here are some example problems to show us what like terms are all about. Check out this algebraic expression: 5x minus 2 plus 7y minus 3x plus 10 plus y. Whew. What are the terms in this expression? A term is a number, a variable, or a combination of numbers and variables, including the sign that comes before it. That means the terms in this expression are 5x, negative 2, positive 7y, negative 3x, positive 10, and positive y. Remember, when a term doesn't have any sign in front of it, like the 5x at the beginning of this expression, by default, it's positive. Today, we're looking at like terms. What do you think those are? Yeah, like terms are terms that are similar to each other. More specifically, like terms have the same variable raised to the same exponent, or they have no variable at all. Going back to my shopping cart, all the shirts I'm buying would be considered like terms because they're all the same type of clothing item. This would be the case no matter how many shirts I had in my cart. In this expression, which term is a like term to positive 5x? That would be negative 3x, because they both have the variable x. I'll label both of those values using the same shape and color, including the subtraction sign before the 3x. Do the same in your guided notes by using the same color highlighter or drawing the same shape around them. You could also put the same number of underlines beneath both terms. 1 underline for this first group of like terms, 2 underlines for the second group, and so on. As long as the like terms are labeled in the same way as each other, you're totally good. All right, do you think that the coefficient, or the number in front of the variables, matters when identifying like terms? Nope. The coefficient just tells us how many of that term we have in the expression. In algebraic expressions, the variable, not the coefficient, matters when it comes to like terms. Go ahead and try identifying and labeling all the other sets of like terms in this expression. Pause while you work. Working from left to right in the expression, our next term is negative 2. What term is a like term to negative 2? That would be positive 10. How do we know these are like terms? Yeah, they're both constants, or just numbers with no variable at all. I'll label them both like this including the addition and subtraction signs in front of them, so it's easier to see whether each term is positive or negative. Make sure you've labeled them both with the same label as each other, even if your label is different from mine. Next up, we have positive 7y. What's the like term to positive 7y? Exactly, positive y. Those two terms get the same label as each other, including the symbols that came before them. There aren't any unlabeled terms left, so it looks like we've labeled all the like terms in this expression. X terms go together, constant terms go together, and y terms go together. Take a look at another expression, negative 9a squared plus 11a plus 3a squared minus 14 plus 5 minus 4a. Would negative 9a squared and positive 11a be considered like terms? Why or why not? Pause the video and jot down your thoughts. The definition of like terms states that the terms must have the same variable and be raised to the same exponent. Even though negative a squared and positive 11a have the same variable, a, they are not raised to the same exponent, so they're not like terms. Pause again while you identify and label all the sets of like terms in this expression. Check your work. What's the like term to negative 9a squared? That would be positive 3a squared, because they both have the variable a and the exponent 2. Both of those terms get the same label. What's the like term to positive 11a? Absolutely, negative 4a. Last up is negative 14 and positive 5, which are like terms because they're both constants. Nice job. I think we're ready to step up to the next level here. Our third expression is, oh boy, 24r squared s plus 6rs plus 8rs squared minus 9r squared s plus 30 minus 21rs squared minus 2. Whew! What's new in this expression? Yeah, we've got two different variables, r and s. We can still identify like terms even when multiple variables are in the same term together, like 24r squared s or 6rs. Remember, for terms to be like terms, everything after the coefficient must match exactly, meaning the exact same variables raised to the exact same exponents. It can get a bit trickier with a bunch of different combinations of the same two variables, but I know you've got this. Give it a try on your own. Pause while you identify and label the like terms in this expression. All right, let's go over this one. What term in the expression is a like term to 24r squared s? That would be negative 9r squared s. Both of these terms have r to the power of 2 and s on its own. It's important to take note of which variable has the exponent. R squared s is different from rs squared. How about positive 6rs? There are actually no like terms to 6rs in this expression. You might have left this term blank because of that, but it is helpful to mark it with its own unique label anyway to show that it's the only term of its kind. Next up is positive 8rs squared, which is like negative 21rs squared. And last but not least is positive 30, which is like negative 2. Nice job today! All this work identifying like terms is really going to come in handy when we want to make expressions simpler and easier to read. Before we get ahead of ourselves though, don't forget to do levels 1 and 2 of the online practice. And of course, keep questioning, keep calculating, and remember, like terms have the same variable raised to the same exponent or no variable at all. See you next time!
Hey, hey.